Hi, I'm Joe Amadimo, the owner of Amadimo Manufacturing. I believe every piece of gear should start with a problem that's missing a solution. I design and manufacture Kydex products and other custom firearms accessories for the kinds of people that carry every day because they know they may need to save a life, theirs or somebody else's. I started Amadimo Manufacturing because I was looking for a mag carrier for my EDC pistol that I could rapidly and cleanly deploy on my EDC belt. Other products on the market that could do this involved taking your belt all the way off, sliding it through, putting it on, or having a completely separate war belt or gun belt. And you know, there's a role for both of those types of products, but what I was looking for specifically, I couldn't find on the market. So I developed this mag carrier. This one is for a Glock 17, but I make them for all kinds of pistols and rifles. But what I needed was a clip like this that I could take this out of the console of my car with a loaded magazine in it and quickly add it to my regular EDC belt and quickly up armor, just carry more ammunition. If I'm in a situation where I'm leaving my vehicle with my EDC pistol on me and I think there's a high likelihood I'm gonna have to draw it, the pistol with the mag in it and the extra mag that I carry in my appendix holster, you know, that's, if I have the option to add more, I would certainly like to get a setup that's more similar to what my full gun belt is with extra mags. So these, I stage them in the console of my car. Two of them, I stage in the console of my car. I can grab them, I can deploy them on my belt. I have a med kit in my car, grab all that and enter the situation that I'm preparing myself to enter. Now that I've spoken a little bit as to why I made these products, I want to talk a little bit on how I make these products. So my very first prototypes were made the same way anyone makes Kydex at home. I had some foam, some wood planks, heated up some Kydex in my oven in my kitchen, put a magazine, wrapped it, clamped it, you know, and that is a good way to make Kydex at home. I'm not going to get into that here. There's lots of tutorials on how to do that on YouTube, many of which I watched and helped me get started here. But my process for making these has evolved quite a bit from a bit of a, let's say, artisan technique to a proper manufacturing technique. And the reason for that progression was that I wasn't happy with the quality that I was making at home. Certainly it functioned, but I really wanted like a finished product to use. And so I tweaked a couple things on how I was custom making them, got them a little bit better, played around with some things like temperature of my oven, how long I left in the oven, how much pressure I was applying with my vices. But still I just wasn't quite there. So I designed I call it a form, maybe you'd call it a jig, a 3-piece mold or form to press the Kydex in to get it the perfect shape. Now this isn't dissimilar from how a lot of major companies make their Kydex products, but they use some expensive equipment to vacuum form it to some molds, and that makes good quality Kydex products. But I didn't have the capital to invest in a lot of that equipment, but I had this passion to make a high quality product. So out of desperation, and with my access to a 3D printer and my knowledge of 3D modeling and 3D printing, I was able to make these forms. And they went through many iterations as well, incremental improvements as I used them to the actual form itself in terms of like its ease of making the product with them. And then also iterations to the geometry of the mag carrier as I used them. But these forms that I make, 3D model them on Fusion 360, made out of 3 pieces. They stack together, fit together nicely, and I'm able to heat up my Kydex in my oven. I had been using my home oven for a long time. I use these what do you call these things? These toaster ovens now. They do it a lot faster, a lot more energy efficient. So I heat up my Kydex, get it to just the right malleability, put it in my form, and then clamp it. And that gives me very consistent, very quality results. I 3D model the jigs and make a carrier, test the fitment when I'm not happy with the fitment, which I've never been happy on the first one so far, maybe someday, but I will make just fractions of a millimeter difference in the dimensions and then print it again and try again, and typically go through a couple of iterations with that till I am happy with the fit. I'm someone who likes my mags a little bit tighter in their carrier. I like that security at the cost of draw speed, but there are 2 screws for adjusting the tension on it. So if you like yours a little bit lighter, you can just loosen up those screws and get them lighter. I mentioned 3D printing for creating the forms that I use to shape the Kydex. In addition to using 3D printing technology for my tooling, I also use it for finished production parts. I 3D print the clips on my mag carriers, and I've chose 3D printing over more traditional methods such as injection molding for several reasons. The first reason is material options. So I can use a lot more advanced materials out of a 3D printer than I can injection mold. So all of the clips on Amedimo Manufacturing mag carriers are made out of carbon fiber infused PETG plastic. Now that chemical composition of plastic and with the mixed in carbon fiber, that allows for the necessary flexibility to get it on your belt, and it also creates a very strong polymer blend with the carbon fiber. And PETG is has very good thermal properties, a very good heat resistance, so it's not something you have to worry about deforming or becoming weak in the heat. In addition to the material options with 3D printing, another great benefit to using it for finished products is the ability to rapidly make changes to the design and bring those changes to market without having to make changes in expensive tooling. This allows me to make improvements to my product fast and cheap. They get out to market faster, and there's no additional overhead cost in changing tooling that has to be reflected in the finished product price. An example of how I was able to use 3D printing to bring improvements to my products quickly and cheaply to market is with my belt clips. This is one of the first versions of my belt clip. It is the first version that was on commercially available products, not the first version on my own units, but it's good. It does what I designed it to do. That's that I can quickly deploy it on my EDC belt. The first versions of it, I had breaking on thicker belts. They worked fine on the belts I had and tested, but once they got out in the world, you stop being able to control all the test conditions, and that resulted in some breaks. So I was able to change a couple dimensions, thicken it up, change some ways of how I was printing it to make it stronger in the axis in which it was bending. And I was able to notify the people that had purchased the clips, and I mailed them out the new clips. So that's an example of being able to get that improvement out to people quickly versus if it was injection molded and I found an issue with my design like that, I would have to invest in all new molds, wait for them to get here, and start making a production run of it before I could ship it out. Another example of that is highlighted by my second version of the clip here, which other than having a slightly different shape, allows for canting on the magazine. So this one can only be mounted vertically. This new clip design allows for 30 degrees of cant in either direction. I've also been able to redesign the clip on the bottom here to make it attach more securely to your belt. Before I wrap this up, I want to let you guys know what you have to look forward to in upcoming videos. So I will be doing deep dives into the design of my products, the manufacturing of my products, and breakdowns of the use cases that the products are built around. If you want to see how this gear is designed, built, and tested, hit subscribe so you don't miss what's coming next. And if you're ready to pick up some gear, check out my website, link in the description. Thanks for watching, and see you in the next one.